given the number of claims n is a negative binomial distribution with mean 6 and variance 12. The size of the claim m is follow this probability, and the s is the aggregate of m with deductible of 1 for each of them. So by using the recursive method, we are asked to find the probability that s is larger or equals to 10. So first, we will convert everything into an Excel sheet. So this is the probability of m given by the question, and we will let p equals to the payment size. So p is 0 when m is 0 and 1, because when m is 0, so the payment is 0. When m is 1, 1 minus the deductible of 1, we still get 0. So the probability of p equals to 0 is actually the probability of m equals to 0 plus the probability of m equals to 1. And for p equals to 1 is when m equals to 2, because 2 minus 1, we get 1. So the probability here will be the probability of m equals to 2. And we'll do the same thing for the others, so we will get this. And for this column, this is actually we're trying to do the probability of p given that p is larger than 0. Means that we are trying to exclude the probability of p equals to 0. So what is the probability of p equals to 0? It is 0.8. So the probability of p larger than 0 will be 1 minus 0.8. So means that for every probability from 1 to 6, we will divide it with 0.2. So we will get this, and this is equals to the probability of p given that p is larger than 0. And the number of claims n follows negative binomial distribution. And the question also given En is 6 and variance n is 12. From the En and variance n, we can actually get the parameter of beta and r. So according to the formula sheet, the En of the negative binomial is actually equals to r beta. So this is 6 given by the question. And the variance n is actually equals to r beta times 1 plus beta. So this is equals to 12 according to the question. So the 1 plus beta here, the extra 1 plus beta here will be equals to 2. So 1 plus beta equals to 2, so we know that beta is equals to 1. And since the En is equals to r beta is equals to 6, and we know that beta is 1, so we know that r is equals to 6. So we know that r is 6 and beta is 1. So we know that r is 6 and beta is 1. And here we're trying to do the revised distribution for n. So for the new beta, we will multiply the original beta with the probability of p larger than 0. So we will get 0.2. And for the r, we will just remain as 6. And the p0 here, according to the formula sheet, the p0 is actually equals to, the p0 is actually equals to 1 plus beta power minus negative r. So this is actually equals to 1 over 1 plus beta power of negative power of r. Yeah, so we will calculate this, and we will get this is equals to 0.334898. And for the A is actually equals to beta over 1 plus beta, but now we will use the new beta instead of the original beta. And for the B, the formula is equals to m plus 1 times negative A. So we will try to find this B using the new parameter. So when we get this, according to the note, the Pn is equals to the number of claims, and Fn is the severity of claim, and Gn is the aggregate. So if we want to find the Gk, means that we want to find the aggregate. So when the S is equals to 0, this is actually the probability of P0, because P is the probability of number of claim is 0. So if number of claim is 0, so the total aggregate loss is also equal, aggregate payment is also equals to 0. So means that the G0 is actually same as the P0. And for G1, so we will use this formula here. So according to this formula, we will apply the F0. So the F0 is actually equals to 0. And then we will put in the value here, the A and B that we found, and the JK is from J equals to 1 up to K, and the FJ, so the F will follow this column. And then for the G, K minus J, we will just use whatever we counted before. So according to the recursive formula, we can get the G0, G1, G2 up until G9. Of course, we can continue, but we are just trying to get until G9. So what is the probability of S larger or equals to 10? So this will be 1 minus probability of S smaller than 10. So S smaller than 10 means that from 0 to 9. So we will use 1 minus the probability of G0 until G9. So we get the answer is 0.031182. So this is our answer.